Hey there, welcome to the online edition of CMIS468. We didn't have enough time or energy Tuesday night to wrap up Chapter 4, so I found a natural breaking point between network management and security management, so this section is going to deal primarily with security management. And as you can tell, I'm at home in my personal library. Yes, we have a lot of books. It's kind of wraps around here, and it's in case you ever wonder if I read a lot, yes, we read a lot. So, on with the show. It is important to point out that you can't talk about network management without talking about security. So I've got a picture of apple pie here to illustrate the point that you need to bake it in. So good security management has to be baked into good network management for the ground up. If you need a reason why, I like the analogy if you can't manage traffic on the highway without managing security/safety as well. One goes hand in hand with the other. I introduced this plan, protect, respond diagram in the previous chapter, so we're going to come back to it. Remember last time we looked at the threat environment of all the different types of malware, ransomware, whatnot that are in the environment. And we talked a little bit about protection with firewalls, with IDPS systems. Now we're going to switch over to planning and look at some planning principles. There are actually 6 security management principles that we'll look at together. Before we talk about the 6 security management principles, just a quick reminder in case you didn't get the message loud and clear when we were talking about network security, that security is not an IT issue. Security is a business and management issue across the board. I'm kind of getting tired of seeing ads on TV that are advertising different security appliances that are supposed to defend your company against things like ransomware attacks or phishing attacks, when in fact there is no piece of technology that's going to fix it without addressing education of end users and whatnot. It also reinforces the negative stereotype. Commercials like the new one from IBM, and maybe I'll show this in class, that reinforces the negative stereotype that security is the IT department's problem. And so IT will come up with some kind of magic box, magic fix that's going to protect everybody from any kind of external or even internal attack. That's simply not the case. In my experience, that's a pipe dream. It's impossible. So until I am proven wrong, security is a management issue, not an IT issue. There are 6 security planning principles, security management principles. I have included a picture of Shiva, the 6-limbed god of Hindu mythology, so I apologize if this is culturally insensitive, but I just needed a 6-limbed being to help you remember these 6 ideas. Number 1, risk analysis. It's impossible to be 100% risk-free. The idea is to lower the risk down to the threshold that the company is willing to accept and willing to pay for. And the only way to do that is to prioritize identify all the risks, prioritize them, decide on the business impact of each risk, multiplied by the likelihood of each risk, and that's going to give you a prioritized list of what to go after first. And then it's just a straight cost-benefit analysis to decide how much money you need to sink into security. The idea is you don't want to spend $1 to protect a dime. Why would you spend $100,000 on security infrastructure when the information you're guarding is only worth $25,000? I don't know. I'm just making up numbers. But you see what I mean. It's while security can be a black hole, a sucking black hole that you can sink money into, these need to be rational decisions that business management is making. I have this in green, but I just wanted to show you an example of the type of mathematical calculation that should be going on here. So what is it that drives your security requirements? Same thing we started off the chapter with in class, and this is big, this is huge. What is it? What is it? Can't hear you. That's right, it's the business requirements. The business requirements drive the security requirements. Live it, love it, learn it. Number 2, comprehensive security. Students frequently get this confused with number 3, defense in depth, which we're getting ready to talk about. Comprehensive security, while it sounds like it's a phrase that means all-inclusive, that's not really it. It's just making sure that you're protecting every possible point of entry into the network. So, for example, closing off your firewall without worrying about your wireless access points as a backdoor is not comprehensive security. If you're guarding all entrances, the firewall, the access points, VPN, any kind of remote access, vendor access, that's comprehensive security. So every possible avenue of attack, every possible avenue onto the network is comprehensive security. If you want to think of posting a guard at every door, that's comprehensive security. Please pay attention to contrast comprehensive security with number 3, defense in depth. Defense in depth just has to do with having multiple hurdles that an attacker has to get through before they can make a successful attack. So not only do they have to get through your firewall and your border router and your ACL list and server security and database security, that there are multiple, I don't want to say layers because I don't want to confuse with the 5 layers, but they have to get through multiple obstacles before they get to their target. As a side note, just an advanced thing, just a sidebar, it's very common to change the IP address scheme in a company's extranet. So imagine 2 routers or 2 firewalls, and there's the external firewall that has your actual public IP address, and then there's an internal firewall that has a private IP address, but then it changes. So from public to private, and then private to another private address range. So maybe on the front side it's a 192 address scheme, but on the inside the actual private IP address range would be a 10-net address scheme. Is very common to do. So changing the IP address a couple of times, the IP address range a couple of times, is another obstacle for hackers to get through. I used to do a long, involved analogy, drawing this up on the whiteboard, describing how defense in depth is just like a medieval castle in terms of there are many obstacles to get through: the moat, the gatehouse, the courtyard, the tower. There are multiple levels to get through. The problem is, it's wrong. This is a bad way of looking at network security. The trendy way to look at security now is a fluid perimeter. What I mean by fluid perimeter is not that there's a liquid moat around your castle. A fluid perimeter means it is constantly shifting around. If you were to draw a network map on the board, and this is what I do in class on the whiteboard, draw up a network and then draw all the avenues that people can access the network. Somebody might be telecommuting from home. That's an avenue to the network. It's on for a little bit and then it's off. Somebody might connect from a hotel. Somebody might connect from an airport. You might have different vendors connecting in. You might have customers connecting in through your extranet. And this perimeter is constantly changing. It's not like you can draw a definite line around, this is where my network stops and the outside world begins. It's just not that easy anymore. If we take this to the extreme, this is Google's approach to security. They don't differentiate between internal and external on their network. They consider every internal device a potential threat on the network, so that the perimeter is around your single device. And there's no such thing as internal or external anymore. That's an extreme way of looking at it. That's an advanced way. But I do want you to be comfortable with the idea of the fluid perimeter. Number 4, you are the weakest link. Sorry, that's an old game show. You probably don't even remember it. So the idea is in a chain of events, even within the firewall, identifying the weakest link. I know when I say weakest link, you're immediately going to think of people. That's not what we're talking about here. I mean, it could be in a way. But if you look at this example, if there's a hardware firewall in place, it needs to be running the latest firmware for that firewall. That could be a weak link. The ACL needs to be configured correctly so that it's blocking the correct ports. The logging needs to be enabled, and then not just enabled but read on a regular basis, whether in an automated way or a human being is reading the log file. I would almost say this is probably the weakest link here. It's possible that the ACL, if it's defective, that would certainly be the weakest link in the chain here. So when you have a single countermeasure with multiple components, these are the multiple components within the firewall countermeasure, and all components must work or an attack will succeed. Each one of these has to be up and running correctly and configured correctly. Now stay with me. Number 4 and number 5 are very similar. Number 4 was identifying weakest links. Number 5 is identifying any single points of takeover. I refer to them as single points of failure, but in a security context, let's call it a single point of takeover. That if an attacker were to gain control of my a firewall control server. More on this design when we get to software-defined networking at the very end of this chapter, but just go with me for now. There can be a box that's controlling multiple firewalls. If somebody gets control of this master server, they're going to have control over all the individual firewalls. So this is a single point of failure or takeover. If you're wondering why would we even have a central point of a single point of takeover on a network? Well, because frequently we try to centralize things just to make it easier to manage. So network management is all about, to put it crudely, centralizing management as much as possible. So rather than having to look at every single firewall, every single access point, telnetting or SSHing into every single router, every single switch, to constantly look at them, wouldn't it be great if all that information was going to a central server that you could manage in one place? It's kind of putting all your eggs in one basket and then having to watch the basket very closely. This brings us to Uncle Tim's Principle of Good Network Design number 2. Just, things I learned in the real world. At the simplest level, if you design your network such that there's no single point of failure, that's smart. That's a really smart way to go after it. So of course you have to have one border router that's connecting your LAN to your WAN. But just because you have one border router doesn't mean that router can't have redundancy built into it. I'll show this to you in class. Or a router can have multiple power supplies, multiple fans, multiple connections, network connections. It can be multi-homed, as it were. Also, it's possible to have two routers or two firewalls that have a failover cable between them, and if one goes offline for any reason, the other one kicks in immediately. So it's not a single point of failure if you have two boxes running in some kind of cluster or some kind of failover configuration, which is typically called HA, high availability. HA, high availability. Number 6, you should only be granting the lowest amount of access to your employees that they need to do their job. So least permissions. Now, access is getting electronic access to a server. Permissions have to do with, in my mind, files and folders. File and folder level permissions. So you get access to a server, you get permissions to a file structure, and you want to limit those permissions. You don't want to let everybody see every single folder on your file server, for example. It should be based on their job. The other phrase I would add to what the textbook has is this is frequently called role-based security, or role-based access, RBA, role-based access. The idea is your role, whether you're in marketing, whether you're in accounting, whether you're on the help desk, dictates what you should have access to. And if we just go back for a second here, there's some vocabulary here that really trips people up, but we need to get precise in our language. So authentication, remember, is proving you are who you say you are. There are multiple ways to authenticate yourself. Username and password, one-time password for multi-factor authentication. There's, retinal scan, iris scan, fingerprint scan, any number of ways to authenticate that you are who you say you are. That is very different from authorization. There's no such thing as fingerprint authorization. That doesn't make any sense. Authorization comes from management. Management authorizes you to have access to a resource on the network. Access is granted by the IT department. The IT department does not authorize you in any way, shape, or form. Why would IT be making those decisions of who has the authority to access something? That comes from business management to tell IT, based on this person's role, here's what we're authorizing them to access. And then IT makes it happen on a technological level. They grant access. Authorization comes from business. Access comes from IT. Got it? Okay, let's take it up a level, up to the 30,000 foot level in terms of how to manage security on the network. And it's got to start with good security policies. And if you're wondering where good security policies come from, tune into Information Security in the Spring to where we're going to answer that question. But let's assume we have good security policies in place in our company. The policy is created by the executives in terms of what it is we want to accomplish with security. We're going to protect our healthcare records. We're going to protect our financial records. The implementation procedural document is how we're going to do that. The policy might be we're going to encrypt private information. The implementation is how we're going to encrypt it. There's a very important equation on this slide, and I've got it in red in here. This formula is having good implementation. In fact, you could add a good policy plus good implementation plus good oversight equals good protection. So notice how there's a cycle here of looking at log files, conducting IT audits, which is something we cover in the new IT audit and control class. That's actually way cool. It's even cooler than I thought it would be. So there's a loop here, and you get the whole thing in the CMIS program, kind of the policy perspective in information security, along with some implementation. Then we've got a separate class on IT audit. So having that whole cycle in place is what leads to adequate protection. But remember, what are our security policies based on? What drives our security policies? That's right, the business requirements. Thank you. And if you'll allow me to do a callback to CMIS 310, where you learned that every single computer is made up of 3 components. Sorry. Shh, I woke up Alexa. She's very angry with me now. Okay, I wish I could backtrack, but I can't. This is a low production video. In 310, we said every computer is made up of 3 things: a processor, storage, and input-output. At a higher level, we said every information system is made up of 3 things also: people, process, technology. I would put it to you that if you're guarding all 3, you're not just focused on technology, but you're focused on good documented processes, which includes policies, and you're effectively managing people, that triumvirate, if you will, of protection is the key to security management. Okay, and now we're going to wrap up by skipping back to network management, just to wrap up a couple of concepts there. And there we're digging into the details. So we've been at the 30,000 foot level talking about security policies. Now we're going to go drop it way down to the technical level just for a second. And it all starts with ping. Number one command that network administrators use to manage the network is just the quick and dirty way to see if a device is up on the network. Also decide if our work is done. I live by the rule, if I can ping it, my job as network admin is done. Now it's up to the server team, the application support team to figure out what's wrong. But if I can ping the box, my network is working just fine. If you need more information than ping can provide, so ping lets you know that layer 3 IP address connectivity is working, that the internet protocol is working. If you need additional diagnostic information, is this switch getting a lot of errors, duplex mismatch errors? Is something configured incorrectly? Is the fan running hot? Is traffic exceeding a certain threshold? These are all things that are managed within another protocol called SNMP, Simple Network Management Protocol. This is the lowest common denominator network management protocol. It's the most common. Every single box you're ever going to buy, ever, understands SNMP. So it's not the most sophisticated, it is the most common. These SNMP traps, simply, or alerts, if you want to call them that, are just text messages, and there are any number of free software programs that can aggregate all these SNMP messages from all your servers, all your network gear, into one console. It frequently gets messy to dive into, so you really want to only turn on SNMP for important devices and important alerts. You don't want to get every single SNMP message. You'll never get any sleep that way. It is very possible that a vendor is going to try to sell you in the future some fantastic network management tool, and it's going to look pretty, and your executives are going to love it. It's going to have this beautiful kind of interface that shows the front of the network appliance, or you're going to have a beautiful dashboard or colored graphics that are showing you heartbeats of your network. All of this is just based on ping and SNMP, and they're charging you for the pretty interface. And if you know how to use a command line, you don't need all this crap, okay? Listen to me. These are just some nitpicky test questions you might see. The SNMP management software runs on a server. Typically, it's just called your network management server. It doesn't have to be a powerful processor. It can be a low-end server that's just running SNMP and maybe syslog. We'll talk about that in a second. But the SNMP manager is talking to an agent on the device. It's not talking directly to the hardware. It's not talking directly to the hardware. The hardware does not have any lips. It can't speak for itself. It can only talk to a software agent that's running on the software. This is why you have to have a managed switch. An unmanaged switch cannot run SNMP, and it's dumb. It can't give you the information you need for diagnostics. So the manager is constantly listening to the software agent on the switch, on the router, on the firewall, and whenever a certain criteria is met, the temperature gets too hot, traffic gets too much broadcast traffic, whatever threshold you've set, it's going to set a trap, which is a weird term that I think comes from programming. If you're a programmer, maybe you can explain it to me. I tend to think of it as an alarm or an alert. And it's going to send that back to the manager as the central repository. That central repository is called a MIB. It's stupid. It's just a database of text, but for some reason we have a fancy term for the SNMP management database. Is called a MIB. I think I told you in class of my experience working with free network management tools. Free is great. There's so many free tools out there. Don't let IBM or HP or Cisco make you pay $50,000 for a network management tool you don't need. Try out the free tools first. All right, we're getting to the good stuff now. Uncle Tim's principle for good network design number 3, just based on my own real-world experience, designing a network from the start for management. And by management, I mean remote management, centralized configuration, ease of remote management is key to being a successful network administrator. So what I mean by that is having the ability to remotely troubleshoot all of the network devices that you're responsible for. A lights out board, oh my God, is awesome. If you've ever used one, you know how awesome it is. But this is more server stuff. But imagine in a server, you've got a card, you drop into the server, and it's got redundant power, a redundant network connection, dedicated everything, so that if your server, and in some cases a piece of network gear, but if your server just completely crashes and you need to reboot it, well, the only way to reboot a server is to, if it gets stuck, is to, just like a PC, hold in the power button and force it to reboot, which means you have to drive into the data center to do that. That sucks. With a lights out board, it's like $50 now, for crying out loud. It used to be $300. But for another $50, if you include that with your server spec, you can remotely get to that lights out board even if the server has zero power and power it up remotely. It's awesome. It saves you so much time. So I strongly recommend you think about that in your designs. Out-of-band management is an important concept for remote support. Imagine you've got a router in Japan that has a problem, and you need to get to it to reconfigure it. But the problem is the WAN interface is down. So how are you going to get to it? Because you need to get to it in band, but that in-band connection is down. What you need is an out-of-band option. By out-of-band, I mean something ridiculously simple, like a phone line. And frequently what you do is you plug in an old-fashioned 56K modem into a spare serial port on the router, connect that to a phone line, to a landline, and that way, in a pinch, you can dial up that modem, connect to it. You don't need a fast connection because you're just doing command line stuff. You're just sending text commands, but you can reboot that router remotely without having to fly to Japan or get somebody to go into the office in Japan to reboot it for you. So that's out-of-band management is important. And then, oh my God, documentation. Kind of like programming. If you're a fantastic programmer but you don't document your code, you suck. You're not a professional, and I have no respect for you. Same thing, if you can configure a Cisco router, an HP ProCurve switch, an Aruba wireless access point, you're just a whiz at configuration, but you don't document what you're doing, you suck. I have no respect for you. You're not an IT professional. Don't worry about job security. Job security comes from being good at your job. What you want to do is progress on to the next job in your career. You don't want to try to keep all that knowledge to yourself. That's called knowledge hoarding, and it's very ugly. So documentation, documentation, documentation. If you don't believe me, being a network engineer has everything to do with being a good writer, because you're writing up those RFPs, which stands for Request for Proposal. That's right. Or an SLA, which stands for Service Level Agreement. Yes. Writing up the business requirements that the business gives you. Writing up project charters for project management. We do this all the time in networking. Writing up new procedures. Drawing out network diagrams in Visio. Yes, I'm going to make you do that. Even writing up your own security policies. You shouldn't have to do this, but sometimes if you're good at your job, you'll be asked to do this. Writing, writing, writing. Okay, the last concept in the chapter is the most difficult. And especially if you don't have any experience managing a network, you just have to believe what I'm about to tell you. Software-defined networking is a new trend. It's a very big trend, and it's a trend that's going to stay with us for the next 10 years or more. It is still picking up steam. You might work at a large company that's in the middle of their migration to software-defined networking. In order to understand it conceptually, you're probably already aware of server virtualization using VMware. Maybe in 3.10 you were playing around with VMware Player, where you can run multiple virtual machines on one server, which allows for greater management, greater flexibility, greater stability in your server environment. Same thing with storage. Instead of having individual direct attached storage to each server, you can have a shared pool of virtual storage space on a storage area network. If we just look at network virtualization as just taking virtualization and applying it to all of our network management principles, you will start to understand software-defined networking. It just allows more centralized management. Now, it's only appropriate for very large data centers. By large data centers, I mean Facebook, Google, Microsoft, Fortune 50 companies, large data centers. I'll try to give you a simple example. In traditional networking, like I grew up with, forwarding and control decisions were made within each box, within each router, within each switch, within each access point. They're making the forwarding and control decisions. On the first exam, I asked what a forwarding decision was. It's just that, how we're going to forward a message, and you're forwarding a message based on the address. If it's a frame going from switch to switch, you're forwarding it based on the MAC address. If it's an IP packet going from router to router, you're forwarding it. The forwarding decision is based on the IP address. The control decision is whether or not it should forward that message. So, especially on a router, you can say, well, maybe I'm going to send it down this route, maybe I'm going to send it down this route, or maybe I'm going to just block it entirely based on the IP address. Now, before we get to the new version, keep in mind that if the forwarding function and the control function are on each individual box, I have to configure each individual box. So this is a piece of hardware that does forwarding, and then it requires a configuration. So I have to manually, command line interface, configure that box. I have to manually configure this box, configure this box. There are ways to speed this up using some scripts. So it's not that bad. But again, when you get into thousands of routers in your network, anything you can do to save time is going to save big money. So in the new era of networking, imagine, if you will, that you can just go to one centralized server and issue your commands, your configuration changes in one place, and they automatically get propagated across the network to every device. Not just routers, not just switches, not just access points, not just firewalls. Everything is all centrally managed. Add to that the benefit of, imagine how much faster each one of these devices is going to act if it doesn't have to waste any processing time thinking about control decisions. All the control decisions are made for them. All they're acting like now is a piece of hardware that's forwarding things at wire speeds. So there are a lot of benefits, theoretically. The big payoff, of course, is being able to shape traffic on the fly. So remember the photos for network management, I was using the analogy of vehicles and traffic on the highway and whatnot. Wouldn't it be great if, depending on the time of day, we could change the flow of traffic, or depending on what type of application was going across the wire, that we could change traffic patterns based on very sophisticated rules. In fact, even rules that are self-healing in a way and kind of change on the fly, that are based on what? What's that you say? The business requirements? Right. You would be absolutely right. Based on the business requirements. That's the holy grail of network management. Automatic network management based on business requirements, on the fly, automagically configured. It's magically delicious. For the test, I think it's important to understand that software-defined networking can reduce costs, but only with economies of scale, only with really large data centers. There's cost reduction. Maybe you need less hardware. You probably need less manpower to support more boxes. And then you have more flexibility. Agility is a fancy word of saying faster rate of speed. That your time to respond to a changing environment is dropped dramatically because the system is responding for you based on predetermined rules. So better, faster, cheaper, that's what we're all about in the School of Business, trying to figure out ways to do network management better, faster, cheaper. Software-defined networking is much more complicated than this. Last semester I had a guy from VMware come in to talk about software-defined networking. I don't know if I can get him back this semester. I've got some other folks coming in to talk to you. The big takeaway from his presentation, the difference between a network administrator making $60,000 a year, great salary, nothing wrong with that, very respectable. A network engineer that understands software-defined networking, has some experience with SDN, $120,000 and up to $200,000. There's money here. Not that money makes the world go round, but money gives you the freedom to pursue the things you want to in life. So if you wanted to find an area to really specialize in networking, you could do worse than focusing on SDN. But it is tricky. There are a lot of certifications that are starting to pop up for SDN. I've given you a couple of video links where you can that you can look at for more information, more background on SDN. Okay, that's our show for today. That wraps up Chapter 4 for CMIS468. And if you ever have questions, please email me, text me on my phone, call me on my phone. If I'm sleeping, it'll just go to voicemail. You're really not bothering me. I want to be available for you guys, but I don't understand the ESP protocol. I don't know what you're thinking, and I don't know what you're struggling with. You have to let me know what you're struggling with, and I'll do whatever I can to help you out. So I look forward to seeing everybody Tuesday night. Remember, we have a guest speaker Tuesday night. Thanks. Bye-bye.